if you can't learn it in 10 minutes, I don't think it's worth learning, guys. So we don't want to belabor the point here. We don't want to make this too long. We don't want also to make histology something that's completely abstract and challenging to learn. Histology should be fun, and histology should be something that's really a whole new world to discover. I really think of histology as exploring into a whole new world, to use a cliche. It's like going scuba diving, except into the body. So we begin this semester by looking at the types of epithelium, and this sketch shows you quite nicely that epithelium is divided into basically two groups. And the first group is squamous, cuboidal, and columnar, but what sets them apart is the number of cell layers. So over here you've got squamous, cuboidal, columnar. There are other cells, but we won't get into them now. The urinary tract has a layer, an epithelium. It's not pseudostratified, it is stratified. It's called urothelium or urinary epithelium or transitional cell epithelium, and it has a very unique appearance, and we'll deal with that when we get there. And the second group is your stratification, and just think of it this way as layers, cell upon cell upon cell. So there are distinct separations. That cell definitely rests on that cell, and that cell definitely rests on that cell. And the reason I'm making that separation is when we define a epithelium called pseudostratification, which is found in the ciliated respiratory epithelium. What in fact is happening there, when we take a closer look, is that the basement membranes, although the cells appear to be on top of each other, the basal layer of each cell is in fact resting on a basement membrane. Which brings me to an important point, and that is that all epithelia rest on, you see that green line? I'm going to color it in red just to highlight it for you. Ears are very good, but it doesn't matter. We want histology to be fun, as is written there, basement membrane. That's what an epithelium is defined as. Part of its definition, put it that way, is that it's cells that are lined up next to each other, as you see there, and then they interface with the connective tissue, but they don't directly interface with it. They actually have a specialized border called a basement membrane. Now, it's very easy to identify histology, obviously, in a sketch format like this, and it's really a good way to start, is to just draw these things. So I recommend having a pen and paper and getting in touch with your artistic side. And that's the way to embrace histology and not to be overwhelmed by your instructors or by your syllabus. And so if you have a look at this one, this squamous cell, it's flattened, almost like a raw egg, and that would be the yolk analogy there. And then the albumin on either side. Albumin, what am I saying? The white of the eggs. So you would have your yolk over here, and then the white on either side. And if you look at a stratified simple squamous epithelium from above, it looks like a bunch of eggs lying next to each other. Let's see if we can get an image. So this is quite a lovely photomicrograph. It appears to be a hematoxylin eosin stain. Don't worry about it for now. It's just color imparted to the tissue. And here's this what I was mentioning, it looks like a little nucleus. It is the nucleus, in fact. It's the yolk of my egg analogy. And then the pink cytoplasm, which is staining with the eosin, if you're in the know, that would be the white of the egg. So all of these are squamous cells. It's actually a cross section, so you're looking at it side on, and then you can see the connective tissue here at the bottom. I'll just highlight that with a yellow double arrow. And so our basement membrane would be running along here, just to remind you. Okay. And so this is a good example of what I was referring to earlier about the sketch being slightly easier, isn't it? The moment you look into this, it's kind of, whoa, where are we now? What's going on? What are these things? You know, and for now, just suspend all questions and insecurities and so on, and just get comfortable with what you're looking at. Look, be with the image, and don't stress. The connective tissue inevitably stains a much lighter color, and the reason for that is this is the connective tissue, the stuff at the top of the image, because there's less nuclear arrangement, less cells, and less uniformity or uniform arrangement of the cell compared to the epithelium. So this is the lining epithelium. It is stratified. You can see lots of, many, plenty, however you want to language it, squamous epithelial cells. The basal layer of these cells is the progenitors, the origin cells of this epithelium, and then they mature towards the superficial layer. Now, with stratified squamous cells, this epithelium is classed either as a dry epithelium, some textbooks refer to it that way, or a moist epithelium. Now, this would be an example of a moist epithelium because the apical, the most superior surface, I know this on your image, on our image, this is to the inferior aspect of the image here at the bottom, but this is in fact the luminal aspect. So it is, when we deal with a circular organ or a tubular organ, then the everything on the inner perimeter of that organ is the superficial layer, or the superior surface, to put it that way. And so in the case of this, which appears to me to be either the buccal mucosa in the mouth, or the esophagus, or even the vaginal mucosa, a stratified squamous, you would call this non-keratinizing. There's no anucleate, non-nuclear layer of cells on the superficial layer. A lot to take in, I know. For now, just understand that this is stratification. It's squamous epithelium, non-keratinizing. And over here we have the connective tissue layer. Okay. Let's just go in on a higher magnification. Let's just go have a look in detail at nuclear and cell structure. So the cytoplasm, if you look at the nucleus, the cell perimeter, there is molding. The cells, they mold almost like they appear to have sides to them, and then others more rounded. If you notice, that's got a more planar appearance, and this is typical for the stratified squamous as it matures towards the superficial layer, and then towards the basal layer, which is at the top of the image here. These cells are round, and it's difficult to see their cellular border because they are maturing, rapidly dividing and maturing at this point. The nuclei are vesicular, and you can see the chromatin pattern, and then in the basal layer they're much more nuclear dense, and we call that hyperchromatic, and as they mature they spread out and become vesicular, so it appears as if there's vesicles inside the nucleus, but that's not the case. It's just a spread out DNA pattern. This is because the DNA is dense and there is rapid division. I'm just wondering if I can move this. No, that's just the pencil. So, not much going on there. If I zoom in, I can move the side here. We can look at some of the connective tissue cells. Of course, connective tissue, I mean, this is where a lot of your immune-based cells are, so defense mechanism. And I've reached my 10-minute mark, and I don't want to continue. Lymphocytes, macrophages, And a lot of this pink material, which has a fiber-like appearance, it stretches across and forms these kind of ribbons across. By what I'm saying is it connects the epithelium to the submucosa, and it's usually comprised of collagen and a few elastic fibers. I'll see you in the next video.